Hello everybody and welcome to the Roots of the Matter. Today we're going to nerd out just a little bit and we're going to talk about capillary action. And the reason why we're talking about capillary action is we want to talk about water moving through a tree. A lot of people don't understand how water moves up and down a tree. There's a lot and we'll probably have many discussions about this, but capillary action is kind of fun and you can see this in a cup of water. If you have a cup of water, you'll see that the water isn't flat. It goes up to the size of the glass, just a little bit. That's called a meniscus. And that is a meniscus because of adhesion and cohesion. So the adhesion attaching to the sides of the cup is stronger than the cohesion, or all the water molecules sticking together. The reason why I'm talking about all this is because water, obviously, it gets sucked up through the roots, right? We all told that as little kids. Water is sucked up through the roots into the tree. Now, it can't go up all by itself. It's not like a free elevator. It has to use capillary action to basically walk up little tiny straws in the tree. If you were to think about it like that, little tiny straws where water can just crawl up. Now, water can only crawl up 33.5 feet before there's so much gravity, so much pulling it back down, it can't go any higher. So that means all our trees should stop at 33.5 feet. Well, that's not really true. Our trees get a lot bigger than that. I mean, look at a redwood tree being 400, 500 feet tall. If we didn't cut them all down, there'd still be gigamongous. Well, redwoods are a little different because they absorb a lot of water with the ocean water and spray coming in, so they can absorb it up high, really high, which is nice. But most other trees aren't able to absorb like that, and so they are able to pull the water up that 33.5 feet through capillary action with the adhesion cohesion of water molecules moving everywhere. But then they also have transpiration, which is basically the pores on the leaf have stomatas. They will breathe out water. So water moves up and it breathes it out, and it keeps pumping it up and up and up that tree. So then you can get a 60, 70 foot tall oak tree or whatever you want because of transpiration. So water will move up so far by itself through capillary action, and then it needs something else to help it grow even taller, and that's transpiration, where there's a little bit of air and water going up and through. It becomes like a little pump. It goes up and through and out the leaves. It's kind of fun. So if you're ever wondering why and how water moves through a tree, hope this gave you a very layman's, simple explanation of capillary action, how it moves through little straws in the tree, basically. And then after the gravity takes over, that transpiration will take over, and it'll help keep pumping up even higher if it needs to go there. So I hope that was really nerdy for you and you enjoyed it. But we'll see you in the next video. Have a good one. Bye.